My name is Qian, and I work from an Ant Group, fintech company in China. And currently, I lead a team of infrastructure SREs to manage our infrastructures. And my main focus is on Kubernetes, and mostly on the reliability and the scalability part. So today's talk is about how to not destroy your Kubernetes clusters. But before we dive into the details, let me quickly do a background introduction. So in the past 3 years, we have already migrated to Kubernetes as our internal container platform. And we use the kube-on-kube architecture to use a single master Kubernetes cluster to manage the rest of them. And we established a dedicated dev team and SRE team to customize part of the Kubernetes itself, right? We use our custom scheduler and some custom controller managers so that they can comply with the rest of our infrastructure layers. And currently, we manage over 100 clusters with more than 100,000 nodes and 3 million pods. And our largest cluster includes 17,000 machines and more than 600,000 pods. Okay, so today I'm not going to actually tell about any systematical ways to manage your clusters. Instead, I prepared several stories for you guys from our Postmodern Database to show you how you actually can see how we actually messed up with our clusters. And the main characters include a powerful operator and a paradoxical finalizer and an evil webhook. Okay, so let's get started. Since I only have about 20 minutes, I will skip some story details, but you can always find me later after the session to discuss more. Okay, so everyone loves the operator, right? You just write a bunch of custom resource definitions, write a bunch of reconciliation code, and let the operator take the wheel, right? So automation is done. And one day, in our internal user group chat, we suddenly saw users started reporting errors to us. So one user simply said he couldn't visit a certain domain. And another user did a little debugging and said, it looks like the service object is disappearing. And they can't visit the service domain created by the Kubernetes itself. OK, so we get more and more alerts and more users escalation to us. So our on-caller decided to take a look. And this is what he saw when he poked around the monitoring dashboard to check the number of services in that cluster. It dropped from more than 20,000 to almost 0. So everything disappeared. And I was around, so immediately everyone panicked, and we started a war room. Yay. And the victim cluster is a production cluster, which hosts over 2,000 nodes and 30,000 pods, and mainly used for our CI/CD jobs and pipeline things. Yeah. OK, so we started the war room, and the initial investigation actually went well. So in less than 10 minutes, we actually located that all the services were deleted from a single IP source. And that IP address belonged to a load balancer operator. But according to the owner of the operator itself hadn't been changed in the past 90 days. And there was no rollout. And in the meantime, we still got user complaints. And the backup cluster for the CI/CD pipeline jobs were also getting affected because of the load shift from this bad one. Yeah. So what we do now, right? So I said, OK, so we just stop the operator for now, to stop the bleeding. And let's focus on restoring the service objects first, right? And our on-caller told me that this cluster was going to be deprecated. And we didn't enable the etcd backup. So there was no snapshot for us to restore all the service objects. So we have to do it manually. And so we collect all the service definitions, from all the logs, contacting dozens of users, asking them and encouraging them to use to self-restore their services, right? Most of them don't actually write plain YAML file because they use pipeline platforms and all the automation tools. So it took us about 5 hours. But what's more, like we underestimated the impact of the cluster of this incident. So about an hour later, we suddenly got paged again. It says like, okay, so the cluster now stopped scheduling pods, and all the pod creation got failed. And the reason was actually not that hard to understand, right? Because when the operator itself like deleted all the service objects, it also deleted the service objects for the admission webhooks in that cluster. So since every pod creation like request needs to go through all the admission webhooks, since the webhook now is not available, then the pod stop, everything now stopped, right? Okay, note that like it took us about an hour to figure out the change because all of us were actually under high pressure and we were busy restoring the services, right? And most importantly, we were very hungry at the time. Okay, so after we fixed the webhooks, so everything seemed to be like cooling down. Okay, so now we finally have time to understand why the operator went rogue, right? Actually, like the operator itself is a custom operator, so it reconciles 3 resource types, right? A custom resource called app load balancer, and together with the corresponding ingress and service objects, they were labeled with app load balancer name as a key to the service objects. Okay, so if the app load balancer custom resource got deleted, the operator will delete the correlated service objects. So probably guess there was a bug. So the operator selected all the services from a neo selector and deleted them. Why? It's selecting from a neo selector because according to the Kubernetes label selector package implementation, it had predefined maximum length on the length of the label key. And that particular length was set to 63 for the standard Kubernetes package. However, we customized it to be 127 in our cluster setup. But the operator was still using the standard library version. So that day, at about 5 p.m., when a test engineer accidentally created the app load balancer with the name of the object length greater than 63, and he deleted it, it suddenly triggers this bug. So all the service objects were being selected and getting deleted. Yeah. So the test engineer wasn't actually like recognize what he was doing, and so everything bloomed. So what can we learn from this short story? Like observability is still the key, right? First, the audit log actually helped us a lot during the initial investigation and later during the service restore. And as you can see, operator itself can be very powerful because when your cluster is getting bigger and bigger, you will attract more users and they will write their own operators. Please make sure they use a common library, shared library version so that they don't have this hilarious mismatch in our case, in our scenario. And also data integrity is also very important to us. Make sure you have your backup and restore strategy tested frequently. And after this incident, we implemented a rate limiter in front of the Kube API server to actually throttle the risky operations like deletions and mutations to avoid another like rogue operator to suddenly delete all the pods in the cluster. All right. So that's enough for the operator for now. Let's come to the next one. This one is called a Paradoxical Finalizer. And this time, I was the actual on-caller. And it's about 4 a.m. in the morning, and I got a paging storm. And it says, like, every cluster is getting trouble and pod creation or deletion. Yeah, we don't have global on-call rotations, so I have to get up and take a look. And it's 4 a.m. in the morning, right? So it's highly unlikely someone is doing a rollout or updating the cluster itself, or if there's like a traffic burst everywhere globally, right? So the only like possible guess left was like maybe it should be a dependency problem, right? And it actually only took me 5 minutes to like locate the pitfall. It was legacy CMDB service in our in the system. So I know every company has a CMDB system, right? And this one actually lasted long before and existed long before we adopt Kubernetes. So we have to do like backward compatible solutions when we do the pod migrations. So whenever a pod is getting created and deleted, we use the readiness gate and the finalizers to make sure like the metadata is registered to the CMDB service. And it's called legacy for a reason, because at that day, the database table, like recording the history of all the like pod creation and deletion, exceeds the 32-bit integer limit, and it's a typical integer overflow bug in the code. But I'm not on call for that CMDB service, so it took me about an hour to figure out, to finally reach out to the on-caller and persuade them to get up and to fix the code. Otherwise, it's going to be a disaster later in the morning. OK, so you thought it's going to be like a simple mitigation, right? You fix the code changing from like 32-bit int to a 64-bit int, and your deployment pipeline would take care of the rest. However, we forgot one thing, is that the CMDB service itself was also like hosted on our Kubernetes platform. Yes. So whenever itself gets updated or deleted, it has to register itself to the service. And since now the service is totally unavailable, now we are doomed. All right. Yep. So we have to do manual operations to fix the deployment pipeline. OK, so I actually like manually deleted the readiness gate and the finalizer to make sure the new code can be deployed first, and we correct the database entries later. And it's lots of toils later. OK. So what can we learn from this one, right? So the first thing we do immediately after this incident was to like remove the dependency loop, right? Since the CMDB service itself is deprecating, we removed it from our critical like pod creation like workflow. And we don't know if there are any other legacy systems in our like entire companies that can have such dependency loops. So we started performing chaos attacks randomly to kill like pods in the production system to see how they're gonna work. And also, we know like how valuable like automation can bring to us, right? But at some certain situations like this one, you need to practice your manual operation skills to make sure you can use kube control quickly and correctly, I think. Yeah. All right, so the last story is about an evil webhook. And this one was, I would call it a near miss, not an actual incident. Yep, it's our poor on-caller again. And in the user group chat, he received complaints from users. And different application owners told him that their pods were getting reconstructed or restarted, but they haven't performed any typical operations like a rollout or a change. And this is our monitoring dashboard, which confirmed the user's complaints. As you can see, like in a short period of time, more than like 7,000 pods were reconstructed at the same time. And this victim cluster was a canary cluster for us, which contains about like 1,000 nodes and like 23,000 pods to serve, I think, 1% of production traffic. And our on-caller was also confused, right? So these pods belong to like multiple owners, and there were no obvious correlations in between. and almost all workload types were getting affected. And some pod actually failed to restart because they were losing states from the stateful set. And we don't know if there is another wave like is coming in or not. However, it still took us a while to figure out like why the pod was reconstructed. The pod spec hash has changed according to the kubelet log, and we figured out the change from the audit log. Again, it was like a security context like change, and we contacted the owner of for this change, and they said, oh yeah, we use a dynamic webhook to inject this change to all the pods, and we want to, it was meant to be a security like enhancement, right? Okay, so we asked, how did you roll out your change? Okay, so previously they said, okay, we use a dedicated label to roll out the change, and the webhook will only inject the security context property if the pod contains a certain label and is set to true explicitly. Okay, but an hour ago, they actually did a rollout to the new webhook version. And the new webhook binary code re-implemented the rollout logic. And now the logic become, the webhook will now only stop mutating the pods if and only if the dedicated pod has the label and explicitly set to false. So if you draw a diagram like what I did here, you would quickly notice that if the pod does not have this label, it will also be affected. And the author didn't recognize this and wasn't prepared for these massive pod reconstructions. So what can we learn from this one? Well, it's actually quite lucky we caught it like in the Canary cluster, because once they roll out to prod, like all like 600,000 pods may get reconstructed, and service interruptions, maybe like we'll get lots of user complaints. So the author itself actually did well when he tried to first design the progressive rollout strategy. But using dynamic webhooks were actually quite dangerous, especially from another team that's not very familiar or on the expertise of Kubernetes. It's from the security team. And we know like audit logs can be very helpful in debugging such incident, but it still took us a long time to actually figure out the change. We need better ways to organize all these monitoring information. And in this incident, actually, we didn't do well on the team collaboration part, because I think for the communication and education to the Kubernetes, it's kind of like people need to speak at the same language. But the security team and I think they are lacking some like knowledge on how the implication of the webhook would work. Okay, so it's already too complicated, so I won't add more details here. Quick recap, like in the past 3 years, we messed up a lot of times. And although the number of like outages and MTTRs number has already decreased, we still believe we have a long way to go. Because we think nowadays Kubernetes is moving from the control plane to the data plane, because more and more like data pipelines and executions requires the availability of Kubernetes itself. So the key takeaways I would like to emphasize are like, first, I think as an SRE, observability is still the key to our success. Make sure you can organize all the information you get from the trace, from the metrics, from the audit logs, and organize them well and to facilitate your debugging. And change management is hard, I think, these days because of the operator pattern and the intent-driven architecture. And make sure you audit your operators with their scopes, their permissions, and their dependencies to avoid the mistakes of the dependency loops and the wider permission problem. And also, like large-scale clusters can have different implications. they actually require like higher data quality and code quality and longer time to roll out new changes. And data integrity is important. Make sure you always do your backup and test your restore strategy. And I didn't cover much about the communication and education, like or the soft skill part of incident management in this talk. But I think the previous talk already covered that a lot. So yeah, I think that's all for my talk today. And hopefully everyone can learn a thing or two from my failures, and we can always discuss more later. So that's it.